Hi everybody. I hope you've tried these problems before you watch the video. It's so much better if you activate your brain first. If we're going to go between exponential and logarithmic expressions, the important thing that we have to remember is that if we see something that looks like a number or a base raised to some exponent equals some power, that's the same as writing that exponent equals the logarithm with that base of that power. And that's the translation we're going to do all across these problems. So for example, if I want to rewrite the following equations into exponential form, 3 squared equals 9, 3 is the base, 2 is the exponent, and 9 is the power. So I'm going to write this as exponent equals log of power with the base. Again, 3 is the base, 2 is the exponent, and 9 is the power. So when I translate into logarithm, it's going to be 2 equals log base 3, because that's the base, of 9. Same thing here. I'm going to write 5 equals log base 2 of 32. This one, we've got that negative exponent. That's okay. We can still have a negative exponent there. Negative 2 equals log with base 4 of 1/16. And this one, I've got 4 equals log base 10 of 10,000. Another way to write this one, since 10 is a common thing, we use base 10 a lot, we could also just write 4 equals log of 10,000. This is called, if the base is 10, is called a common logarithm, because we use it a lot. So anytime you see a logarithm that doesn't have a base on it, you can assume that it's base 10. This last one, x is the exponent here, and so I can rewrite this as x equals log base 5 of 500. And that's how we're going to end up solving exponential equations. If we want to get a variable out of the exponent, we got to rewrite as a logarithm. Now this one, it's not clear what x is just from what we're doing here, because 5 squared is 25, 5 cubed would be 125, 5 to the fourth is 625. That's too big. So we know that x is between 3 and 4, because 5 cubed is 125 and 5 to the fourth is going to be 625. So 5 to the x equals 500 has to be in between there somewhere. We'll talk about how to get that in another video. Let's go on and look at this one. Let's evaluate these log expressions by translating into exponential form. So for these problems, since I don't know what the log is, maybe you can guess based on what we've been doing, but if you don't know what the log is, you can say it equals n, and then translate it. Here's the base, that's the power, that's the exponent. So this is going to be 8 equals 2 to the n, and hopefully you know that that means n is 3. Similarly here, just make it equal n if you're not sure what to do. The base, the power, the exponent, so 81 equals 3 to the n. And again, we can check powers of 3. N is 4, because 3 squared is 9, 3 cubed is 27, 3 to the fourth is 81. Here again, I've got 1/4 equals 4 to the n. And if you remember what we were talking about with the negative exponents, n equals -1, because a negative exponent means take the reciprocal. Log base 10 of 100,000 could also be written as log of 100,000. Remember, if we don't have to write the base 10 in there, but it translates into, if we make that equal n, it translates into 100,000 equals 10 to the n, and that's going to be 5. N equals 5. This one, if I make it equal n, it says, nope, yes. No, I don't need to say log again. I'm going to translate an exponential, because 5 is the base, -25 is the power, n is the exponent. So -25 is equal to 5 to the n. And you notice, how can I raise 5 to a power and get a negative number? We can't do that. So this expression, log base